Hi all. Today I am discussing the solutions of linear simultaneous equations. Let's see. Solutions of linear simultaneous equation. Let's go to my first example. It is x plus y is equal to 4, the first equation, and the 2x minus y is equal to 5, the second equation. We know that we can eliminate if I add first one to the second one, 1 plus 2. This is 3x is equal to 9. X is equal to 3. If we substitute x is equal to 3 to the equation number 1, 3 plus y is equal to 4. Y is equal to 1. Okay, then it's a solution. 3 and 1 is a solution. If I plot these two graphs, they meet at a point. The point is 3 and 1. Okay. However, in this situation, this linear simultaneous equations have a unique solution. That means there is a point they meet each other, or there is a solution. Unique solution. Okay, let's go to the second example. The second example is example number 2 is 2x plus 3y is equal to 7. It is my first equation. 4x plus 6y is equal to 12, the second equation. We will try to solve these two equations first. If I multiply the first equation by 2, 4x plus 6y is equal to 14, the third equation. If I take 2 minus 3, then this is 0. 12 minus negative 2. Negative 2 is equal to 0. This is not possible. This is not possible. That means, no, they don't have the solutions. Now, when we draw them, this is 4x plus 6y is equal to 12. The other one, 2x plus 3y is equal to 7. These two lines are parallel to each other. That means they don't have the solutions. Then I'll go to the third example. What is my third example? The third example is 2x plus 3y is equal to 6. It is my first equation. 4x plus 6y is equal to 12. It is my second equation. If I multiply the first equation by 2, 4x plus 6y is equal to again 12. The third equation. Now we can say both of these equations are same. If I sketch these two graphs, they overlap each other or they coincide each other. Both of them are the same. Here, they are two straight lines, they overlap each other. Now I am going to consider three examples that I have discussed earlier. Yeah, this is the first one. The first one is x plus y is equal to 4 and 2x minus y is equal to 5. We know that this pair of simultaneous equations have a unique solution. Then we will consider the ratio of the x coefficients and ratio of the y coefficients and the ratio of the constant terms. What is ratio of the x coefficients? It is 1 over 2. The ratio of the y coefficients 1 over negative 1. Ratio of the constant terms 4 over 5. We can say 1 over 2 is not equal to 1 over negative 1. However, it is not equal to 4 over 5. The ratio of the x coefficient is not equal to the ratio of the y coefficient. We can say the set of simultaneous equations have a unique solution. A unique we can't generalize with the ratio of the constant terms. We will see another example here. This is another example. X plus y is equal to 1. 2x minus y is equal to 2. If I add them, the first equation and the second equation, 1 plus 2, 3x is equal to 3, x is equal to 1. If we substitute to equation number 1, x plus y is 1, y is equal to 0. However, there is a unique solution. 1 and 0 is a solution. If we consider the ratio of the x coefficients, what is it? 1 over 2. Ratio of the y coefficient is 1 over negative 1. Ratio of the constant term is 1 over 2. However, the ratio of the x coefficient is not equal to the ratio of the y coefficients, but the ratio of the constant term is equal to the x coefficient. In general, we can say if the ratio of the x coefficient is not equal to ratio of the y coefficients, the pair of simultaneous equations does have a unique solution. Okay, now we will go to my second example. The second example is 2x plus 3y is equal to 7 and 4x plus 6y is equal to 12. Now we will consider the ratios 2 over 4 x coefficients, 3 over 6 y coefficients, 7 over 12 constant terms. However, we can see the ratio of the x coefficients is equal to the ratio of the y coefficients, but it is not equal to the ratio of the constant terms. This pair of simultaneous equations, the ratio of the x coefficients is equal to the ratio of the y coefficients, but it is not equal to the ratio of the constant terms. That means if the ratio of the x coefficients is equal to the ratio of the y coefficients, but it is not equal to the ratio of the constant terms, they are parallel lines and no solutions. Okay, if I go to my third example, it is 2x plus 3y is equal to 6, 4x plus 6y is equal to 12. If we consider the ratio of the x coefficients 2 over 5, y coefficients is 3 over 6, constant term is 6 over 12. 2 over 4 is half, is equal to half, is equal to half. That means the ratio of the x coefficients is equal to the ratio of the y coefficients is equal to the ratio of the constant terms. Then we can say this pair of simultaneous equations have an infinite solutions. In general, we can summarize what we had done. I do have two equations. First one is ax plus by is equal to c. The second one is px plus qy is equal to r, where a, b, c, p, q, r, they are real values. Okay. Now we will consider the ratio of the x coefficients. What is it? A over p. Ratio of the y coefficient is b over q. Ratio of the constant term is z over r. If a over p is not equal to b over q, then this is important. Sometimes it is equal to one of these ratios. We can say there is a unique solution. If a over p is equal to b over q, but it is not equal to z over r, the ratio of the x coefficient is equal to ratio of the y coefficient, but it is not equal to the ratio of the constant terms. That means they are parallel. These two lines are parallel or no solution. Then the third one, if a over p is equal to b over q is equal to c over r, the ratio of the x coefficient is equal to the ratio of the y coefficient is equal to the ratio of the constant terms, means infinite. So in my next video, I'll be tackling more questions on this topic. Please subscribe to my channel to watch my new videos. Thank you.